Morning. Can you hear me all right? Okay. Quite morning. Do you like the room?
I like the room.
Yeah. Okay. So by the way, take all the cookies and leave nothing behind, because this is all for you guys. It's like. Anyway, for those of you that just came in the room, just set up. No rush. And let me tell you about this workshop. The good thing about this part of the workshop is like this is quick and not so complicated. Morning. All right, that's the spirit. Water, coffee, tea, and cookies. That's what you need to do IT stuff usually. All right. Hi. So why don't we get a little bit philosophical? Hi. Hello. Morning. So I usually start with the following the following question. So everybody's a scientist here, or there are engineers here? I mean, one engineer. Okay, so sorry for you, man. No, but really, the question is the following: what's the strength of science? What is one of the strongest features of science? Just say whatever comes to your mind. Replicability. Okay. Well, that's one. That's the theme of this workshop, right? that gives you away. You can reproduce stuff. Like one of the strengths of science is that you can predict the future, right? You can do predictions depending on the pattern you actually are looking at. But the other part is like you should be able to replicate the same thing over and over, independent of where you are. Either you're here or in China or in South America or in the United States, wherever you are. It's like we have also conventions, right? Like 1 meter here is 1 meter everywhere else. So it doesn't represent, this represents the fact that it doesn't matter what do you believe, what's your status, like an alien or not, illegal or here, foreign or whatever. A meter is 1 meter anywhere else, right? So taking into account that, let's start with this thing. So just to present myself, my name is Didier Barradas. I am part of the KBL team. I am not a computer scientist by training. I'm actually more like a biologist rather than a computational guy. However, the paths of science took me all the way to HPC science and computer and reproducibility and all the good stuff. So here you see my team. I'm part of 2 data scientists in the team that you can reach out, tell us about your problems with data, your grievances, and so on and so forth. Or for example, we have Ronald, that he's the VR resident expert. He can visualize so many things that you could not imagine. His projects are so cool. And James, thank you, James, by the way. I know you're watching. He's pretty much the one that set up this room, but he also can do visualization of big data sets, like, for example, the weather predictions that you see on our other room over there. He's responsible for those things, for example. Now, if you don't know, now you know, we have a YouTube channel for these things, meaning that this workshop is being recorded and it will be there later for you to watch. If you have to leave before or you have any other question or comment, like and subscribe. You will find pretty much all the basic things that we deem that you should know. For example, even there's how, if you're a Windows user, again, sorry about you, but there is also a tutorial there how to set up like your computer for data science, like done by my friend Abdul Rafur Halimi. Also, there is some things about IBEX over there, because I give also a workshop of data science on HPC. So you can check it out whenever you want. But let's start with the first question. Is like, what is Conda? So back in my days, when I was a very young gamer, you have to start by installing a game, and then you have to install something to crack the key of that game, which might be very bogus. But then you're required to install a bunch of things that might crash into your computer. That was called dependency hell back in my days. Nowadays, less and less is being taught about that, because you don't need to install everything every single day in one single computer. As a matter of fact, you might already know we have the cloud, and each cloud is basically one instance of a computer. It gets created, it gets destroyed, and so on and so forth. Conda is one of those tools that will allow you to install libraries in your computer without breaking it. And this is important because I have a very good friend that happened to be very brilliant, but very rough when it comes to managing his libraries. Why does that matter? Because when you install a library, if it's for Windows, it might be a different encoding for Mac and different encoding for Linux, which means that your results will vary. Or even worse, you will install something new, and then you will break your complete environment of all the libraries that you have. All right. So why would I learn Conda? One, because it's a tool that is platform agnostic. Second, you can install everything with there, almost everything. It's not only Python. It's like you can install a bunch of other things. Like if you don't like to write code with Python, you can install R, you can install Ruby, Java, Rust, if you know what is Rust. Your GCC compiler, meaning all those libraries that you need for basically your scientific work. The gist of this is that every time you do a project, you can start a new environment, a virtual environment with Conda that will basically isolate that part. And then you can start installing stuff there without breaking the others, which is actually a very good thing in advantage, because then for each project, you have your own set of libraries that will work for that project. And you can basically ship it to the next guy that is going to work in that project. Okay, just a disclaimer. This workshop that I'm going to give you is basically based on a thing called the carpentries. These guys, if you are in a beginner stage, this is the source material that you need to read. They have everything from how to program with R, Python, this Conda. Right now, even they have a workshop about deep learning. And I am a certified instructor from this organization. This is why I'm actually using this material. But if you have to give this class and you don't have a starting point, go to these websites of the carpentries. You will find some material that will help you give also some workshops or your class. Okay, so to start, if you don't know, now you know that we have a web page that is called wiki.bis.kaust.edu.sa. Please go to that web page now and try to find that training events, the small part I put in the left, and try to find also the data science tools workshop series for this now. Why? Because we will be using that web page now. You will find the Conda there. Okay, so please go to this website and you will find Introduction to Conda and FAIR workshop, which actually brings me to tell you this is a very special workshop, because it's not just me giving I'm going to give half of the workshop. The other half is going to be on Dr. Julian Gorenflot. Did I say that correct? Okay. So. My French is not quite good. But he's going to be in charge of that other part. And you will find there something like this. Like there's going to be a web page that says workshop materials. You will find these slides over there and also how to prepare, and you will see it there. So do you need another second to see the web page? Yes. Okay. Which, by the way, if you see that web page, it has all other trainings over there that we, the KBL, is providing. This one was the last round of the last semester about what I did. I did only Git and PyTorch. You will find also the other workshops history down on the bottom. All right, all good? Did everybody find the web page? Yeah, this is last year. Well, like this is on April. The days are different, yes, because we are updating all the time. Yeah. So the thing is, like, it's always the yellow one. That's my block. Okay. So when you're clicking Intro to Conda, you will see a different page than this one. This one is the old only Conda workshop. Now you should see the Conda and FAIR web page. And it has also a couple of links over there. Okay? Nice. So in the how to prepare thingy, well, before that, I usually prepare something called Class Hub that will allow every user of KAUST to actually work on this thing. We're not using that for this time, okay? Why? Because it's actually something that I want to test. There is a thing called Binder that is available for people that is watching this in YouTube or for you here without installing anything, okay? Just click and go. So for those that are Mac users, you could actually use your terminal, or for Linux users, you could use also a terminal, if you know what a terminal is. But the gist of the thing is, like, you have to also install an Conda installer. But now, for those that are already here and do not want to install anything, please go to the GitHub repository. You should see something like that, like in the web page says something about Binder. Go there. It should lead you to this website. And if not, go to this website. You will see GitHub, KAUST Introduction to Data Science Workshop. You will see something like this over here. Introduction to Data Science Workshop. It's one of the first ones that you will see. Okay? When you scroll down to the README part, you will see a button that is called Launch Binder. But now that you're here at KAUST, click the Launch KAUST Binder. There are two of them. The Launch Binder is going to launch a generic binder outside KAUST. And this one is very specific, dedicated for you. Okay? So just click there in the Launch Binder because it will take time to actually load all the libraries and all the things. Okay, is it running? Okay. It should start running something. Because it should be something like this. You go here, there are two buttons there. You click in Launch KAUST Binder. It's my mouse here, this one. And then you will see a window that says something like Binder that you see here on the bottom. And then it will deploy something called Jupyter Lab. Okay? It will take time. The binder thingy is going to be basically working, is building a virtual machine for you. And at some point, you will stop. It will stop and it will deploy something like that. I will give you a moment to go to the website. Click over there. All good? Yeah, it's inside the binder. Okay, so you deployed, okay, if it deploys already, okay, just raise your hand if you could deploy it. 1, 2, 3, okay, nice. Press testing, oh, good. Sometimes it's not that fast. Yeah. It usually takes a bit of time. Well, if you don't like this, there is also the possibility of you installing the Anaconda Navigator. We at KAUST, we have this in the self-installation software. You click there, you install it, and if you want, you can work like this. You will find then a Jupyter Lab option where you can basically tick, and it will deploy this. And this is what you should already have also with the binder, some interface like this, correct? Okay, so in that interface, what I want you to do is to use the terminal. Now, for those of you that are new to this thingy of computer science, terminal is the best way to work in the sense that it's very powerful. However, it's a way to speak to the machine. And it's not quite like just speaking English. It just has its own language. You just have to know the key phrases and keywords. Okay? So everybody got to that? You didn't? Not yet. Okay, don't worry. Yes, question. So for this workshop, we're going to use the Jupyter Hub terminal because everything has installed, but you can use your own installation using Anaconda installer or installing locally, and then with the terminal in your computer, in your Mac, in your Linux, or even in PowerShell, you can use Conda. That's the idea. Conda runs everywhere. You can install it in Windows, Linux, even in our HPC cluster, mostly in our HPC clusters. Okay. Did you get all the way to this? Yes. Okay. Good. Okay, if we are pretty much everybody in the same UI, this is what we are going to do. Basically, this is the entire workshop. There is nothing more about Conda in the sense that the mission of Conda is to create a virtual environment for you, and then you work. And then you destroy it if you don't like it, you rebuild it if you like it, you do the stuff. But basically, in my opinion, this is what I use most of the time, which is Conda create. Then Conda create in a particular place in your computer, meaning probably in your project folder, or you remove everything, which is very normal because it's like, you don't like the environment just crashed, you remove it and you recreate it. Pretty much. Then is Conda install, is the other one that is like, let's install everything, or let's install something new, let's install something that I don't know. For example, R, and you just create an environment for R. Then just to know what's inside of an environment, you can basically list all your environments, or you can list even what's inside of an environment. But that's just for you to know what is inside of the thing if you're not sure about the versions, about the names, about everything. And of course, how to activate and deactivate, like enabling or disabling, because you will have so many. For example, currently I have like 20 or about, I don't know, like 10. But for example, a question I always get is like, how many environments should I have? Well, as much projects as you have. For each new project, start a new environment. It's basically good for you to have everything isolated. So the projects doesn't crash with each other, even though they probably are merging or they're in the same line, doesn't matter. Okay? So in your terminal, I want you to type this. So right now you're in the IDE, type which Conda, and then enter, and there type Conda -- version and enter. Right there in your terminal. Conda version and Conda help and enter. Okay. Yes. Each time you create an environment, yes, it will install all the libraries. However, it depends, like, are you using the same kind of libraries? You install anything. But if you're going to install new things and you don't know how compatible they are, just create a new one and start building. Yes, it could be very prohibited in the sense of how much storage you have. For example, in HPC clusters, in the one that we have here, we do not advise to put everything at home because it has only 200 gigabytes. But if you have 1 terabyte, you can host many, like super, yeah. So right now, I'm going to repeat what you did. Basically, you came here, right? This is the KAUST Visualization Core Lab GitHub page. You go to Introduction to Data Science. You click here. You scroll down, and you launch Binder Hub. You see this binder thingy running, and I will join you in a second about that. Okay, now you have this nice IDE or developer environment, right? So you click here in terminal, and you will see this green big thing, correct? So when you do Conda -- version, I should match yours. Your Conda version is also 24.3.0? No, 11. Yours is faster. Well, better, actually. Well, in that case, by the way, if you don't want this, you just click here, and it will open the window. If you don't want this, you can do export PS1 equals, I don't know, like this, okay? And then it will basically take out all this thing, and you will have more place to work with. Again, this will be export like this. You can add this, or you can add this. And then Conda. There's no help here. That's strange. Export PS1 will take out the green part. Here it is, -- help. So export PS1 is going to take out this part, which is called also prompt. And because it is very, very, very long, because you're running in a virtual environment, this is computer, KAUST, BizLab, blah, 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 blah. This code over here. This is a machine that is basically allocated to you right now. But because it's not allocated to your computer, it just tells the environment, well, this user is called Jovian. And this is why the first thing that you see there is Jovian add something. So it's not you, it's some random user. In this case, I put PS1 just to get rid of all of that and have more space to work with. So if you do -- help, you will see, for example, I misspelled Conda help there. And it tells me there is nothing here that is just help. You either use -h or -- help, like I did here. And then it will allow you to see all these commands. Now, all these commands are basically directives of Conda. This is what you will be using all the time. However, if you have some kind of question, for example, what does activate do or clean, Conda, let's say activate. This should work. Yes. So if you want to see what everything does, you just have to go and put -h, and that -h will deploy what each of these commands is going to do. And literal small explanation, and then how you could use or what other options there are. Okay, so far so good. Everybody join me all the way here. If you do /h, that's curious. It should work like this. Conda activate /h will help you. Okay. Yeah. First is the command, is Conda, the command, and then -h, and it will deploy something. Okay, so far so good. Everybody join me all the way here. Everybody has their own virtual machines and everything? Great. Okay. So let's clear this. Now, if you see, you probably can see these folders and everything in the machines. However, let's start with the basic. Let's create our first Conda environment, okay? So the syntax is very straightforward. Conda create, let's give it a name, -n, we can give it a name. In this case, we're going to call it messy, okay? If you just type this, it will start creating something. However, basically speaking, you are creating a folder. There is nothing installed inside. It will just create messy. That's it. Nothing inside, just a placeholder. Fine. And you see? Do you want to proceed? Yes. And then it tells you, if you want to work with messy, then do Conda activate messy. You see, all the way here. By the way, is the font okay? Should I blow it up? It's okay? Nice. Okay, if you do Conda activate messy, like this, now something will appear in the bottom. Let's clear this again. Clear. So as you see, there will be a parenthesis and messy. That means you are now inside of the virtual environment that we call messy. All right? Yes. You have to start with Conda create. Actually, yes, like that. If you do Conda create -n messy, you create something with the name messy. Okay? Now let's give it another go. Conda, let's deactivate. So I'm back to square one, basically. Now let's do Conda -n TR7, because football. And then here's the catch. -y, it will automatically stop asking me if I want to create and proceed. It just basically says like -flag y is enabled, meaning you want to just proceed. When I take that one out, it tells me, do you want to proceed? Okay. And if you go to Conda create --help or -h, you will see that this is the flag. Okay, I just added something. It's the usual thing to add. Conda creates your name and then -y because you don't want to be basically asked if you want to proceed or not. You just create it. Okay, so far, so good. We have two environments. Now, how do I know about these environments? Conda environment env list. Okay? So Conda environment list will give you basically the list of Conda environments you have. So no surprise there. Very quiet and very simple. You create things with Conda create, you list them with Conda environment list, and so on and so forth. So far, we have two environments, CR7 and Messy. Both are empty, but now you have them in your computer, and you can work with them. You can install different things inside of them. Okay? All good? Environment notebook in this case is the default environment that we have in the virtual machine. So this is why I call notebook. In the case that you are actually working in your computers, it will be becoming base. So this is very, very specific for the notebook. Now, how do we install packages inside? Who wants to get a shot? Yes, tell me. Uh-huh. Yes. Uh-huh. Mm-hmm. Yes. When it tells you, do you want to proceed? As a matter of fact, let's do another like that. Let's call this Maradona because I know you come from Italy. So if you do Conda create something, without the -y, it will ask you, do you want to proceed? And then you just type y and enter, and it will create the thing. And now, because we have created 3 different environments, if we do Conda environment list again, now we have CR7, Messi, and Maradona. Sorry for the football reference. But at the end of the day, you just can create as many environments as you want. Yes? No. You cannot create an environment inside of the environment. Because in theory, what you want is that these things are isolated by itself. Now, if you have activated one environment, you can create a new environment, but it will be put away in the sense that it will be an independent thing. For example, if we say Conda activate CR7, now I'm inside of CR7, but if I do Conda create, let's put Pelé, it will ask me to proceed, but again, Conda emp list, you will see that Pelé is not inside. And how can you be completely sure that it's not inside of CR7? Because here in this right side, you can see the actual complete path that is one enabled because of the asterisk, and where is this folder now? Okay, so the whole philosophy of Conda is you have a complete isolated environment, one from each other, because you don't want them to cross. In theory, you want each of them separated because there are libraries that doesn't play along, or there are older versions, or different things. Yes? Can you replicate or do something like a copy of the environment? Yes. And I will let you actually answer that one. Why don't you do, again, conda -h and tell me which command can do that? Right, conda -h, and you will find out. Over there, another question. Yeah. What's the difference between names? I should say, like, Conda is kind of repetitive. Sometimes you will find that it's exactly the same because there are two ways to do the same thing, usually. But for example, yeah, I use basically Conda create minus n or Conda create minus p because p is about the path. If I want to put something in a very specific folder, and we will see that in a minute. But yeah, name is. Okay, so which is the command that can create basically a copy? Export can create actually a list of things that are inside of the environment. And that's a way to create a copy. You can basically export what is inside, and then you can give it to a friend, to your colleagues, and then they can replicate your environment. That's the whole idea of this, that you give a very simple list, and they can basically replicate what you have in your computer, work with the same things. Conda minus h. Amazing. There is another one, Conda amp minus h. They take it away from here. There used to be another called clone, but apparently this version doesn't have it. But yeah, export is one of the ways, and it's probably the best way to do it, how to create a different thing. And also lightweight, because a text is not that difficult to just give it to each other. Okay, so Conda, deactivate. So far, Conda amp list. Okay, we have already 4 different environments. But what if I don't want to use basically the default placement for that one because it's eating away some basic storage? Well, you can create another folder. Let's create nkdir. Something like this. So in this case, I just created a folder called Al Nasser, badly written. However, I can tell basically the same Conda create minus p could be like this. Hopefully it works. So the thing is, I didn't know. Okay, yes, it did work. So in this case, you see the change here? Also, you should notice that this doesn't have a name anymore. What I just did with minus p is to tell Conda, I need to create a folder over there in this location. Okay, that's a trick. And that's a very nice trick to have when you have a very small partition and then you have another place where you want to put this. Also, it's a good practice if you have a folder with all the things to run that project inside, and then you can just zip it and launch it from anywhere else, in theory. Okay? So the creation is very simple, as you can see. It's just Conda creates something, and then you basically give it a name or you give it a path, an absolute path. What I did here was just first create a folder, and it could be a folder of whatever name. And then I tell him, like, go to this place and create that. All good so far? Okay. Yes.
I want to give me results, but I don't want to. Just want
to. You're asking me a shell question rather than a Conda environment.
Yeah,
okay. So if, by the way, if you're not actually familiar with this terminal and shell thingy, there are two things that you can do. One is you can read history, and you will have a list of everything that you have written in the past. Okay, this is something very Linux thing. As a matter of fact, if you do something that is called reverse search, but we're not supposed to talk about it now. However, you do something like exclamation point 21. This will actually trigger what you did in that line again. Shell is very powerful. The terminal itself is very powerful, but that's not the topic so far. However, if you don't know what you've written so far, you can just type history and you can copy paste. That's it. Okay, just this is a different thingy, but however, we're working in the terminal. Okay, so far so good. How about a 10 minutes break? So you can have cookies, water, and other questions. Okay? Okay, questions first. History is not working for you? Ah, that's curious. You just have to read history, but we will check it. So yes. Like you give the path that you want to create. Yeah, as a matter of fact, look at -p. -p will create the folder. Yes, you're right. So the question was, where is it? If I can do this thing, but if I didn't create anything before, will it work? And the answer is yes. If you, come on. If you basically say something like workshop, it will just work. Okay, you don't need to specify. Sometimes you need to specify where you want to put it. Sometimes you don't, but yeah, it works anyway. All right, so break. Do you want some coffee or tea? Or we can just keep going. We keep going, or we break. Break. Okay, 10 minutes break. Yes,
Question.
tell me.
So I'm using the Conda, like I have the Conda installed.
Uh-huh.
Sorry, but I want to use the GitHub. I don't know how.
But you are here with us in this. So if you go here in terminal, it opens a terminal here, and you have the same environment as we are doing here.
Okay, so I just have to type what we have. Okay.
Yeah, just create stuff. It's not a problem. But like this.
So I cannot have access again to the same other.
No, because this is a virtual machine. It's completely different.
Okay.
Yeah. Okay. So for those of you that are, what happened to this guy? Okay, this is alive and well. Okay. By the way, that's a QR code for you to give feedback. If you don't like the material so far, you can tell me there. But most importantly, there is one question there that I want you to answer, which is like, what do you want to learn next? Because I have a series of different workshops that in theory are available, but I need to know which one are most popular. Okay, so for those of you that are just joining, there is this web page again. In this web page, github.com/kaustbizlab/introduction to data science. Go to this web page, and then you can start the Binder Hub if you don't have an Conda installed on your computer. Okay, you just click in the button that says KAUST Binder Hub, and it will kickstart basically the same IDE that we are working with. Okay. I just need to know that everybody is basically on the same page on the terminal. Okay. Ready to go? Nice. Okay, so far so good. Let's clear this. So again, we have created Conda list a bunch of different workshops, folders. We have the Al Nasser, we have workshop, we have Pele, we have Messi, Maradona, CR7, all your favorite stars from football. So what if I want to install something, right? Because so far these are basically empty. So that's very simple actually. And let's start with Conda install. Now, Conda install -h again will deliver you different options that you can explore, like update and like path, channel, and so on and so forth. Now, as you can see here in the example, you can use -p or you can use -n. We can use Conda install -n CR7 and let's say Python equals 3.7 and then flag Y. So what I'm writing here basically is telling, go ahead, install Python 3.7 inside of the environment I created. Okay, you will see this kind of these kind of labels going on, popping up. And then nothing has changed in my environment list, right? But I installed something inside CR7. Now let's create Python 3.9. And this is just examples with Python, by the way. You could do another stuff. Now, Conda install message Y is the same thing. Again, this will go check something, and it will install Python, a different version of Python. Okay, so if you're carefully looking, where is it? All the way on the top, it says something about channels. Now, channels are, technically speaking, libraries of libraries, meaning like, think about these channels as Wikipedias for different stuff. Now, they're going to be relevant if you are using, for example, a very specific thing for a private company. Like, for example, NVIDIA has its own channel for its own packages to use in GPUs. Conda Forge is basically the Wikipedia for all the libraries that are basically open source and available for you to install, like GCC or like Rust, like I mentioned, or all the versions of Python that are right now maintained, or alt. So we're going to specify, or the best practice is to specify the channel that you want, because by default, it will try to pull everything from Conda Forge and defaults, but defaults sometimes are not up to date, okay? However, now that we have installed something, we can Conda activate messy, and then do Python, that's just version, and it says it's 3.9.23. Conda activate CR7, and we do the same, and it's Python 3.7.12. Okay? Now, this is important. Why? Because some of your projects will be developing some specific Python library, and those are not compatible with another libraries that are more modern. Some literally change words and everything comes crashing down and you cannot work anymore with that library. But that's the idea behind Conda. Now you have two things that are completely different, because from version 3.7 to version 3.9, there are several changes. If you go to 3.12, it will be completely different world again. Yes, question? Can we set all the higher level? Yes. So can we manipulate what version of Python we want? Absolutely. As a matter of fact, if you do Conda install, let's do Conda install, and let's just put Python over there. And we're going to do it on, wait. Ah, yeah, Pelé, the best player in the world. Yeah, sorry, it's the best. But okay, so if I don't put, or I don't specify the version of Python that I want, it will go for the lastest version. Yes. Excellent question. What happens if I don't put -n, right? As far as you can see, like Conda install -n, it will put things on Pelé, right? But if I have active CR7 and I just do Conda install SciPy, it will go for the last version that is compatible with the Python that is inside of this environment, and it will install it inside of that environment. The default is what's activated. If we type Conda,
Conda install Python. that's the architecture without that
Very
it overrides the older version of Python.
Let's try it. What if we have already installed Python inside, right? Will it update it or not? In theory, no. It should be like, okay, I already installed Python. What else? Do you want me to do something? That's a very good question, as a matter of fact. Okay. So here right now, if we do conda install Python, just like that, let's take the -y. It's telling you, warn, please update your conda. All requested packages are already installed. So it doesn't actually update things because it doesn't overwrite the version you installed unless you specifically are telling. However, that's not the point of Conda. If you want a new version of Python or any other library, start a new environment. Just like that, yes. No. When you want to update something, if I want to update right now the Python, okay. Like this warning here for Conda specifically. Yeah, it will update mine, but it will go and basically change the base, the one that it says notebook. That's the one that it will update. Is the Conda baseline. But if you want to update the package, then is Conda -h. This update or upgrade option is the one that you have to enable, the one that you have to search for. Yes, another question. Is it possible to upgrade or downgrade? Upgrade, yes. Here is the question resolved. However, if you want, again, if you want to upgrade or downgrade anything, create a new environment. Do not try to upgrade or downgrade stuff. Just do something that's going to isolate that you're not going to touch, create a new one. Can you update everything? Sure. Will it break something? I don't know. Maybe your code. So that's the thing. That's actually the risk we want to avoid. Okay? So the same goes actually for -p. If we do -ipy -p workshop, we put -y, it should work as well, okay? Conda install has then three modalities, -n, -n, -p, which one is for the name, the other one is for the path. And then the default is always where it is actually enabled. Please be careful, because my very good friend that was very brilliant, he never actually specified where he wanted his libraries. He just start installing everything in the baseline, in what we call notebook. That's a bad practice. Don't do that. Do not install everything on base. That's completely against the philosophy of the whole thing. Create.
You know what, I do that because I just want everything in one place.
That's perfect. Create an environment where you have everything in one place and leave base clean as possible. Because the day you want to create another thing that is different and you don't want to break all the things that is in that specific one that you love so much, then don't break it. Just create another thing. All right. Okay, so I'm back to the base. Let's clear this. Okay. Let's put this a little bit like this. Yes, good. So what do you want to see when you are dealing actually with what you have installed? If you have everything installed in your base, and you want to know exactly where it comes from and what the version is, you can use Conda list. And again, it has -n, -p, and also the default will be what is activated. So if I do Conda list -n, you will see all the libraries that he installed just with Python. And it will be Python 3.9 alongside all his cousins and friends that are compatible with it. If I do it for CR7, right, yeah. Then you have Python 3.7 alongside all his cousins, but it also will have SciPy, which is a difference between one and the other. And these are all compatible, okay? If I do it for Pelé, I have Python 3.13, which is the lastest one. And if I Conda and list, if I do -p workshop, I also see all the things that it installed. But if I do -p al-Nasser, it's empty. Okay? We haven't done anything in al-Nasser, just like certain people that place there. But then you have also like the power to see what is different in each of your environments. Just list the things, and that's fine. You will see right out of the gate what you have installed and what is compatible, and most important, the channel where it comes from. So for my bio friends, usually they use channel BioPython. For my AI friends, they use usually the channel NVIDIA. Yes. Think about it like a Wikipedia of libraries that somebody has a very interested vision of using. Python 3.9? Very good. Yes, so if we do Python and -name, messy, and then you do Python, and then you say like equals 3 point something. So this equals 3 point something is in the jargon called pinning version or pinning the version, meaning that you are installing specifically that thing for you. And you want specifically that version. 3.7, it could be 3.9, 3.8. This is your example of Python, but it also can be your GCC compiler and other stuff like that, which, by the way, brings me to the point of telling you, in our HPC cluster, this is the way you don't wait for us to install stuff. We actually tell people install mini Conda or Conda so you can manage your own software and you don't wait for us a week to tell you, oh, we installed it in, now it's here. Use it this way. You can right away just write it on. Okay. So, like we were discussing about how to create now a copy of the things that you already did, right? So in this case, we have Conda export, and then -n. Now, Conda export will output this ugly thing called YAML file. This YAML file can be output to literally something called environment.yaml. Okay, you can save it like that. The thing is, this is the way you basically give a copy to your friends about your environment. You can see here that each line has a very specific version next to a very specific hash, which means that that's very specific for my Linux machine. Okay, if I give this to my friend that is using Windows, he will not be able to replicate my environment because this is a tag very specific for my operating system. How to avoid that? you go and you export and you say no builds. So these no builds will take that tag out, and then you can share it with your friends and your mother and your father. Okay? Because if you have that last tag, you are just going to make people cry because they cannot take out that flag manually. Well, they could. But imagine that it's like 1,000 lines here, and you have to go and basically erase all of them. Meaning that if you have something like that, what I mean is the difference between this and this. You see that red thing that I just highlight there? That's the thing that is specific for Linux, the red one. So you cannot give this to another Linux, maybe. But if you do the no builds thing, then everybody's happy. Second thing that you should notice, all the way to the bottom, is that thing called prefix. Okay? This prefix, we have to get rid of it. Why? Because that is actually telling, in my computer, this is the path where it's saved. This is where you will find these libraries. It doesn't make any sense if I give you my path to my computer, because I'm not giving you my computer, right? At least not at gunpoint. But so what can we do? We just play with something really, really easy. We said, in Linux at least, head minus n minus 1. And now the head minus 1 will take that out. Now, that's the Linux way to do things. You just have to open this whenever you want, wherever you want. Like, for example, in this thing here, this is basically a word path. Okay? In any word path, you go all the way to the bottom, and you take down that prefix. Then you save it, and everybody's happy. BI? Yeah, don't follow me in BI, please. But anyway, so if you're trapped in BI, this thing is called a text editor. This is pre-Word, pre-everything. So to get out, you have to basically do the 2 points and Q and enter. So you see in the bottom, the 2 points, Q, enter. Now that's for old stuff like me, but you have this IDE version here, so you can open all the files in a more friendly way, and you can edit them here. For example, if you don't want this to call messy, you can pull it null, and you can save it with Control S. Okay. Yes. How to import an environment. Good. Okay. So in this case, you will be doing how to import something. If you are given an environment YAML, that's the easy way. Now there is a catch here. Conda emp create is basically the -file environment. This is the way you import things. If you are given a YAML file, you have to enable now the keyword emp to create that environment. And then you will be able to import it. Now, in this case, I'm going to do -p and put workshop 2. So I want it there. And it will kickstart the process. Okay? If you have environment YAML that you have from anywhere in the world, This is the way you import everything. Now, given that that person that gave you the YAML file was kind enough to put the no builds flag, this is easy. It will go as smooth as this. And then you can install all the libraries that they have in your computer and start working as if you were in their computer. So far, so good? Yes? Requirements is for pip. And YAML file is for Conda and other programs. Those use YAML file because it's basically a recipe of what you have to import. Requirements is for pip. Pip install is something that I do not like because in the original pip, there was no careful thought about what is crashing with what. And still to this day, pip just get rid of whatever he wants and install whatever he wants, and then breaks all your libraries. So when you pip install something, I think you should just do one pip install that is not conflicted with everything. It's like all the requirements do not conflict with anything, but it's alongside the same. Now, the other different aspect is like pip is only for Python. You cannot install any other thing. But Conda can. Conda can install a bunch of other things. It can install R, Ruby, Java, and Rust, and so on and so forth. Pip is very good to just do it in a one sweep file swoop, but it has its disadvantage. Yes? Like a copy? It is possible with just a copy with shell. However, we do not recommend it because the links will be broken or could be broken. And the second is like, do you guarantee that that machine is a clone of the other machine? No. I mean, specifically speaking, is your machine, your XCD blah architecture the same as the M1? Or that's what I mean. It's like, can you assure me 100% that the machine you're going to pass it to another machine is a clone? Then you can basically copy paste everything. However, if it's not, if one is an Intel Xeon and the other is an AMD something, it's not going to be the same. You can use this one. It will take time, but it's better. Okay, so we're just on time. And for the next trick is like, okay, let's get rid of everything, right? How do you remove stuff? Usually, how do you remove everything? Or you can remove a specific package. But I'm lazy and I usually just remove the whole environment. So in order to do that, Conda -H. We just have to go here. Just save this here. And this is the command that we're going to use. Conda remove -H will give us more in the insight. So you can, like in here, remove a very specific set of libraries, or you can remove everything. And this is what I like to do usually, because sometimes it's so broken that why bother to just, I will just rebuild it. So Conda temp list. Let's Conda remove. Okay. Which one of the lists do you hate the most? I would say Maradona. Yes, go with Maradona. Let's remove Maradona. Let's go with this guy. And then you say --all, y. So this command will basically say to the computer, go check whatever is inside of this folder called Maradona that was created, then remove everything and clean this space. And the -y will say, like, don't ask me if I want to proceed, just go ahead. destroy it. And because it was empty, it just went ahead. And now Maradona is gone. Okay? How do you, exactly, good question. How do you basically, let's say, erase Al Nasser or workshop 1 or workshop 2? So in this case, instead of -n, you use -p. And then you give the path. So if I want to do this, it just tells me what is actually happening, like what is removing. Execution done, and now it's gone. So like you see, Conda is very repetitive. There are many ways to do the same thing, but usually use -n or -p. Then a couple of flags, and then you can destroy one thing or many things at the same time. But again, the philosophy is to have everything contained in one place. Yes, question? Can I create an environment that has no name and no path? Not that I know of. It's like if you just do Conda create, it will tell you like, so give me a name or give me a path.
No risk, for example, I go to the directory home,
No.
I create an environment without name.
No. There is no conflicts here. It's like once he finds one name or that matches, it will tell you automatically like this is not going well. Okay. So for example, let's create again. Let's go over and erase everything, and so on and so forth. So go ahead, erase all the Conda environments you created. And technically speaking, that's what you have to know about Conda in our context. Okay? In the sense of create something that is completely isolated. However, one final touch, and it's about pip. Thank you for bringing that up. So the Python community is very keen on using something called pip installer. Now pip, like I said, has its downfalls. It is very good because it's basically one command that installs packages and packages and packages, and you just have to do one line. However, when you want to upgrade something, or it just goes and delete without question or checking if it's conflict or not. So in that case, what we recommend is that you go and let's say you are here on the, activate. Okay. So let's say that you want to do pip install. You usually do this. So pip install will basically go and install that library that I have here called Seaborn. However, there is a risk. If you are in some kind of environment that is shared, or even if you're in your certain computer, there is no guarantee so far in this line that it will bind to the environment. Meaning, if I do this, if I do pip install like this, it will just pip install somewhere something. So in order to do this, if I want the Python from this environment to be linked to this installation, and all the links, all the virtual links are in sync with this, I have to do this, Python -m. So once I trigger this, then the pip install will find the Python of my environment and say like, you installed these libraries. Okay, I will find these other libraries over here to match your version. What I mean is, in CR7 I have Python 3.9. In my notebook version, I can have Python 3.13 or 3.12. So without Python -m, there was no guarantee that it was going to be the Python 3.9. So once you do this, it's a normal pip installation. It takes 1 second and it will just link to one each other. Right? Yes, question. What's the purpose of -m? That's Python 6 syntax, but if I recall correctly, -m is minus major. I forgot really. The purpose of -m is basically telling like execute this program. It's like if you are basically telling like Python -m and there's a script in front of it, it will execute the script. But I don't remember what's the M stand for. But it's different than -c because -c is basically command line. And like basically it will, you have to type what you want from Python to execute. This one basically executes the program that is in front. Once more, this one. Let me clear that for you. Control C and clear. So this one was the command. Now notice that I'm inside of one environment already. So pip, you better activate first the environment and then the pip install. Just to be completely safe that you're not going awry. Ori. Okay.
What you're saying is that make sure that library will be useful to the library
Yes.
itself.
Yes.
As compatible with the environment.
Yes.
That's the main purpose.
Yes, that's the only takeaway that I want you to take from
and
this.
If I just activate the environment,
when you do that, when you just pip install without Python M, you have the probability that it will install it somewhere else, not with your Python.
but within the same environment.
Usually it works like this, like it will take the environment Python and it will install it. However, this is a double safe. It's like, for sure it will be linked to this Python. Because I have seen it in the HPC cluster, which is a shared environment. You do the pip install and it installs it somewhere where you don't have access. It's like, why in my environment is not installed this if I did it with pip? And then it's like, because it's thinking that the Python that is enabled is the other like main framework Python, not the environment Python.
That's the reason why.
Yes, that's the reason why I want base to be clean. Base should have like nothing on it.
So what if I do the old practice?
How to fix it? First, start by creating an environment file, like the YAML file. If you want to get all the libraries that you have installed, name it environment YAML. Then reinstall Conda. Clean everything, like literally clean everything from the start. You restart Conda, create a new environment, and then in that environment, you install the environment file. And then you have something isolated. That would be my way to do it. You can go and basically uninstall each of one of the different libraries you have done with remove, but it might take you a while and you don't know what the end result is going to look like. That's what you want, of course. Okay, so far so good. So you know how to create environments, how to remove them, how to export them, and basically how to install things inside, right? So, any other question? No? Okay, perfect. So now we can take a break. And then we can jumpstart the next phase, which is the FAIR data. Okay? Very good. Oh, where is... Okay, let's take a break.
now I see. Okay. Yeah. Okay. Looks good. Yeah. So welcome to this second workshop or second part of the workshop. It's the first time I do this. So you know, I haven't had so many iterations of it. First version, you are my guinea pigs a little bit, kind of. So yeah. So what we are going to talk about today is fair data, and most important, a tool to produce and handle some fair data. I'm going to come back to it a bit later, but fair data is a relatively fresh concept. The kind of founding article is from 2016, I believe. So it's going to celebrate its 10 years old very soon. And so, in contrast, for example, to Conda, which is a very nice environment handling tool, there hasn't one tool that has emerged, which is generally accepted as the main thing. There's a lot of solutions which are under development. There's a lot of things happening, and Nomad is one of them. And it's been designed for material science. And so, at the end of the day, that might not be the one you are using, but because this is a very important concept, important development of the way we do research, I thought it's important that you get familiar with one tool to handle fair data, and you can transpose this knowledge to whatever tool you're going to be using, even if it's not Nomad itself. So yeah, my name is Julien Gorenflot. Some of you may know me. I've been around for 9 years now here, including 7 years as a material scientist in solar cells, and 2 years now, or 1.5 years, let's say, trying to promote fair data in KAUST. And so in this presentation, I'm going to be jumping around a little bit. So you may want to have those things available before I start. The slides, you had them already. I'm going to click them too to check if the links work. The slides, you have them on the web page of the training already. The one I'm using now is this one. So this training is largely inspired or adapted from a training given by FAIRmat. It's a German consortium who is gathering people from many universities in Germany and in the world to develop this fair data platforms. And they are the people behind Nomad, really. And so they have some training regularly on YouTube, and the 4 groups here are from their training, and mine is this one. The one you're seeing now is adapted from that. So you can either use a QR code. You can take them from here on the workshop webpage. If you click, where am I? Here, it's going to bring you to the same place. It's going to bring you here too. So I encourage you to download the slides because, because there's some links on it from time to time. It's going to save you some time if you want to click them and to follow along. Exactly. From this same page, you can also go to the root of this training here, and you're going to have here also some files that we will use later for examples. So you could also take them from there. That would be useful for you later. And otherwise, once you have those slides, you can also access them for the same thing from here. This brings you to the same place. Yeah. And there, from here again, you can have the slides. And the files. What else? Important also is Nomad. It has hands-on training, so we're gonna go to this Nomad. Yeah, tell me. Really? Oh. Hmm. Works here. Can you try to download it and then open it with whatever application you have? Otherwise, oops. Otherwise, you can use the links. You can open those links there already to access the files, especially. That's going to be the most important. Anyone else has problem with opening the PDF? Oh, it's okay. So yeah, I think all the time I have the links. So in the worst case, even if you don't manage to see them, you could type the link, but it would take some time, or use QR codes to access the links. We can also have a look at the break again if we can manage to do something. I can send it to you directly. Okay, other things gonna be important is of course Nomad itself. It's okay. Nomad itself, so that's the platform. That's the platform to store data. It's a repository plus all the tools to access, to input and output files and display and sort files from this repository. Well, in that case, the address is, well, if you've downloaded the PDF, you have the link, but otherwise, the address is fairly easy. nomad-lab.eu. And you will need to create an account for the third part of this tutorial, the part in which you have to upload you have to learn to upload your own data. So if you haven't done it yet, please do so. We can also do it again later. The two first parts will not need an account yet. So yeah. And from time to time, I will use Menti to poll you a bit. This will come back. That you can use directly from your phone. So this is a tutorial in which you're allowed to play with your phone, but only when this sign arises. Okay. Yeah. Has everyone managed to get the slides? Okay, then let's start. Yeah, good. So what we're going to do today, there's more or less 4 parts in this workshop. And part in which I will just speak a bit, explain you a bit about fair data, about Nomad. And then 2 parts in which you are going to play by yourself, hands-on parts for exploring, filtering, using data from Nomad. And then uploading data. And then I will just, in the end, show you, if we have time, a few more advanced uses that are possible. So, yeah. So let's start. So So about fair data, the thing before fair data really is if we want to maximize the impact of our research, we really have to be able to use data from project to project and correlate it with data that could come from other laboratories and other platforms. Like if you see an example of data from whatever project, let's say an article in which you study some application which has a certain efficiency as function of a certain parameter. And okay, it's nice, you get some information, maybe you can publish this, but it gets much more powerful when you can correlate it with what other people or what you have published before. Then you can really get a large view of what's going on for this application you are working and how this parameter is controlling it. And of course, once you do that, you can really find a model for it, for example, and this is very impactful. This was a natural materials paper, a lot of citations, works well. So this is a cross project, but ideally you also want to compare with what the rest of the world is doing, and this is an example of it. Can I get a better pointer, maybe? This one is taken from Nomad. This is a solar cell application, but that doesn't really matter. Point is that you can compare with all the solar cells that have been created across the world, at least those which have been uploaded there. And you also want to compare across platform. If you are studying one system, it gets very nice if you can put together through the same platform some data that come from spectroscopy, some toxicology studies, some any kind of study you have on it, or even marketing, why not? So that's really what you want to do. That's really what you want to do in the future, and it's very powerful. As I said, this is a natural article. This was also just correlating, a few tens of systems from different studies. But if you can correlate more, gather more data, obviously, you can really see what parameters correlate with which one. And even more important, in the way our world is doing, you can run machine learning on it. Because AI works very well and very often it's been used on video packages, image packages, things that can be produced massively. But if each point that you want to study takes you 1 year of study, you're not going to have enough data to run some AI on it unless you can really gather data from the whole world and from all your previous studies. So this is about the motivation and what this is all about, really. And so how does FAIR data come into it? That the people in Nomad, so this is the official abbreviation, but they call it findable and AI ready. But really it means findable, accessible, interoperable, reusable. Findable means you can find the data, locate it, access it, accessible. So typically it's going to mean that it's properly identified with a unique identifier, it's referenced, it has a place to live, a repository, and there's a metadata around it that enable you to filter and to search what you are interested in. Accessible, it can be mistaken for open. It doesn't necessarily mean open, so you can make your data fair while keeping it to some extent for yourself, but it means that you give people the instruction on how to access it. So even if it's not open, maybe you can want some money for it or something like this, but there's proper instruction and proper rights defined on how to access it. Open is better to some for some, but you don't have to want to have it open. Interoperable means what you were saying before. 1 meter is the same here, 1 meter is the same there, 1 meter is the same there. And this should be true for any information that is in your data, which means you have to use standards that makes that your data can be understood by any platform and any system. And reusable means, well, it's mostly the consequence of all the rest, but it includes that it should be properly documented to know really in which context it can apply and how to use it safely and what you can compare it to. So That's all I'm going to say about FAIRdata. If you want to know more, I have more presentations later. I have like 20 minutes, I think, is a publication ethics seminar on Tuesday. And then I have a longer presentation for the library training week on October 15. Feel free to join. I think there's a lot of interesting things to discuss there about FAIRdata and about what we want to put in place in KAUST to use it. But what I want today is more, give you some hands-on experience. Long run, I would even like some of you to become developer of tools for FAIRdata. And so that's what it is about. Well, the slides, you already have them by now. Nomad, I hope you managed to access it. We'll come back to it later. And as I said before, it's largely derived from the presentation that the people from FAIRmat and Nomad did about this, which you can find on YouTube there. So Nomad now. So as I said, Nomad is a platform which includes a repository in which you can put the data, and it's secured and backed up and preserved for a long time period. And it includes the tools to put there. It includes the licensing. There's a juridic tool to protect your data there, and a tool to put the data and put them out and visualize them. And so how it solves the problem of findable, well, as I said, it is a storage places. It is searchable, and it has unique identifier for the data you put there. The licensing is including, you have proper referencing to all the authors or related resources about your data. It is using standards. Everything has filters and fields you can use to understand the data, and it can also use electronic laboratory notebooks for which you can really put all the information. And because those electronic laboratory notebooks are shared, someone else wanting to use it is going to use exactly the same standard as you. And it has APIs to programmatically access your data if you want to reuse it fast and on a automatic way. Exactly. So yeah, let's get started. Did you remember the address of the? If you have the slides, you should be able to click, I guess. Right? Let me check if I put the hyperlink on it. Yes. Good. So this is the Nomad entry website, and what we want to do is to open Nomad. Come eventually. And this is how it looks like in the front. So what you're going to have to do later is maybe register here, or in my case, I will have to log in. And yeah, it's organized from this tab on top. This is going to have all the documentation. These are very general information about nomads. One more relevant, most likely, are usually in the docs, in which you can find more tutorials for all kind of applications you want to develop or to use it for. As I said, it's a very young field. It's all very dynamic. New things are created and getting out all the time. So you may find some resources a bit outdated, or you may have problems which no one bumped into before yet. So a very important thing for this is their Discord servers. They are very responsive on Discord. Usually you get a response within 1 or 2 days or the same day, depending how complicated your question is. And if you want to join Nomad, this is a good thing to have also. Exactly. The rest of it is organized around the analysis. So to use the data, it includes the tools to export them, to use them outside of Nomad, to export them maybe to some machine learning algorithm. We're not going to talk of that today. It's a bit out of the scope of this, but it exists. What we're going to do today is first figure out how to get the entries, how to sort them, so explore a bit the data. You can see here that that enables you to already get to some more specialized versions. Some are experimental work. Maybe some of them you are familiar with. And some are more like theoretical calculations. And the second thing we're going to work with is how to upload your own data, which is around here with this publish. So out of this control bar, what you find is, well, the entries themselves. So as you can see, there's currently like 19 million, a bit more than 19 million entries in it. Mostly from computational calculation, because this goes faster than experiments. But there's quite a few experiments too. And then you have the filter bar to select whatever entry you would like to see. So, for example, if you are interested in a given material, you may want to have, I don't know, hydrocarbons, for example. Let's say some carbon and some hydrogen. Look. And already you are down to 2 million entries, a bit more than 2 million entries. So this is the way you can do. You can also look for different properties, anything you like to see. You could have a band gap, for example. You can use those filters to narrow down your research to whatever you are interested. We're going to apply this. An interesting thing also, so you can do that manually, but you can also make that programmatically. And to make the link between them, if you have to figure out by yourself what are the right lines of code to code this, it might take you a bit of time, but you can click this button on the right, which gives you directly the corresponding code to this filtering action or to the actions you have carried out manually before. So it could save you some time if you want to make things programmatically. And on top of those filters, if you don't really know in which category is what you're going to be looking for, just clear the filter there. You can also type there, you wanted a band gap and you don't know in which property it's going to be, you can type band gap, for example. And then you will find electronic properties, band gap, for example, and then value equal something like this. Or you want to look all the articles by me. You could find like this. I have only 4 which are shared. I have more which are not shared, but you cannot access them from here. And what else? We can look. Another example. So Claudia is the one who started this. So she has a bit more input than I. And let's take one of them as an example, maybe this one. So those are all entries. And if you click one, you get a very small overview of it, what material it is, a few of the metadata that come with it, so the data about the data. And to really open the entry, you use this arrow here. Yeah, and give you the entry again. So this is the same metadata that we found before. What kind of, in that case, the computational thing. So what kind of computation has been carried out on this system. And what they call some cards. So for each type of data, you have different cards. So here you have a card which tells you about what kind of material it is. Here you see it's a 2D material, it's a surface, number of elements, certain symmetry it has, the calculation that's been carried out on it, reference, if it's been published, you would have, for example, you could have, or if this material is used somewhere else, you could have reference to these other entries that use it. Yeah, exactly. That's how one entry look like. Yeah, that's it. That's what we need to see to get started. So, did I forget something? I don't think so. Yeah. So this one is for material science, but it has, for example, it has a computational chemistry or computational thing like toxicity functional theory. So if you would have, for example, some protein calculated, also some biological molecule calculated from there, that could work too, to put the result of those calculations there. And everything, it's all open. It's all bottom up and open. So you can develop the filters or the tools that are missing to put the data you want in it. But really, what I want to show you is how to access or explore, navigate a database like this, a repository like this, sorry. Exactly. Yeah, so let's get started. You all managed to open Nomad? Everyone is there somewhere? Good. So in this first part, what we're going to do is to search entries a little bit and see how you can visualize the results. So they are all as small exercises. If you click this, I think for this part we go slowly enough, but if you get lost or yeah, you get distracted or something, you can also go to this step-by-step guide and you're going to have the solution very detailed. It comes. So the details of what we are doing, but step by step, really. All these exercises and how to do, where to click, and so on and so on. Or you can also check again the video on YouTube, or well, this one is going to be on YouTube too. So you have 2 videos you can check. And yeah, let's get started. So, for example, could you manage to find how many entries in this database have boron nitride, are about boron nitride in a hexagonal structure? And you can use this Menti to give me your answer. I probably just have to open it first. Now that's the risk, because I have my this open. You may see the response before. Let's see. Hopefully I can try to start the presentation before showing you the answer. Out. Oh, too late. It's already. Don't look here. Good. Now you're going to be able to give me the answer. Here, this is a question again. You can access the Menti by scanning that. You can do it with your phone, so it's not gonna take space on your laptop. And oh, can give me the answer. I'm gonna also wait. So if you have those slides open, I can go to the Menti webpage so that I can see your responses appear. So I can see how many of you have managed to find the answer. Give you a few minutes and I will look for it too. That's interesting. We get different answers. You can tell me if you want me to display the other page again. If you haven't had the Menti yet, you can also use the link up there to access it. instead of the QR code. How many are we here actually? Waiting. Of course, I counted you, but I forgot the number immediately. Yeah, tell me.
The entries, how can we
So if you go to your Nomad page, so go back to the entries, yeah. So here you see you have a filter which shows you the numbers of entries. So if you close this, to reset it, and then you can try to add the right filters, and you will see here the number of entries. Okay. So let me come back. Let me do it. You will see. So we want. Oh, here the hints. You can use the hints also. I'm gonna make it in same time as you. Where did I put my? Nomad. So the hint says to go to filters, element, formula, and we're looking for boron and nitrate. And there's a trick. You want things, or not all things that contain boron and nitrate, but things that has only boron and nitrate. So we can click this one too. And that already reduces your number of entries to 8,262. But then what we want also is the one with hexagonal structure. So there the hint is to use the structure and symmetry filter here. And you scroll down until you find the one which is about the hexagonal structure. And here it is. And I get 2,786. I'm going to write that 2. Unfortunately, you cannot write the exact number on let's see, but the closest one seems to be 2,800, I guess. Yeah. Sorry? Ah, this was the one that came, so oh, you may not read it very well from here. Can I zoom like this? Exclusive, which means it's not going to take all which has some boron and some nitrate, but the one which have only boron and nitrate and no other element with it. This one appeared when I checked that box here from the formula. Okay, so 2,786. That's what I have here. Where's my Menti here? And yes, that's the answer I obtained yesterday. I think most of you managed it, so congratulations. Within error bars, close enough. Good. So now, next one. What is the range of the band gap of those entries? So don't remove your filters, and let's try to find information about the band gap. Oh, not in presentation. No, just remove it. No. up. Here you can type directly the answer you found. Move this one. Why don't want to go? Okay, we're getting there. Okay, it's getting closer. Good, good. So well, you get numbers, but somehow I get different one from what I remembered. Yeah. Oh, I know why. Okay, so let's look for it. So band gap can be found, as the hint was saying, in properties electronic. Properties here electronic. I'm going to look for band gaps, and there you have this visualization, and that's the one that gives you the answer. And the answer to the question is really those. So you may not see here, but there are a few points in this area too. It looks like there are only there, but no, there's also some there. So the correct answer is this, 3.928 EV to 7, a bit more than 7 electrovolts. Exactly. The answer? No. So this one, so here I haven't applied any additional filter. Okay, I applied a filter which is towards the one which have a band gap, because some of the entries don't have a band gap. So this is, okay. Okay, that's what you answered. I see. So this is the number of entries that has a band gap. Okay, I see. Yeah. Yeah, good. And so, but the question was, what is the range of band gaps within those entries? And you can see, you can visualize that here. And this is the range from about 4 to about 7. And now the next question is going to be, within this range, how many entries is there between 5.9 and 6.5 electrovolts? Oh, sorry, I should move this one so it can give the answer. Ah, yes, that's the answer. How do you put the answer? So the way you would do that is, like this. So we say 5 points, how much? 5.9 and 6.5. So let's go 5.9 and 6.5. You need to type manually to refine a bit. Here we go. And yeah, the right answer is free solutions, free inputs. So those are all calculated things, and those one actually are closer to the real values that exist experimentally. Good. So that was for theoretical calculation. Now if we go to some actual experimental data, and let's say a scenario, you are studying solar cells, and you want to make a solar cell like this. So this is a device creating some currents when you illuminate it from under. And you're considering to study this kind of solar cells. With some electronic contact, some absorber, and some transport layers. So first of all, want to see how many entries are there which have those materials, no matter if solar cell or not, but how much entries exist with these materials. No, I went the wrong way, sorry for that. Yeah, exactly. So, well, you know already now how to search materials, so I'm going to go faster. And so we've changed topics. I'm just going to click remove all this. The problem is here, the material you want to find are what? Cesium, lead, bromide, and iodine. Could take some time to find them here. Okay, I find the iodine here. But yeah, so what you could do is add them like this. So you want an element, and yeah, you find how the element variable is called, and you just write you want it to be bromide, for example. Took. Then we wanted cesium. Here we go. And what was the last one? Bromium is there. The lead. Oh, so the dangerous one. Element equal, oh, there's a space, equal lead. Yeah, so that's it. We have, we can also add this filter again that makes that we consider the one which have only these elements. And here we go, 2770. Is that what I wrote on Menti? I hope so. Blah, blah. Yeah, no, I wrote the wrong one. I forgot the filter to have only those elements. Okay. Oh no, because the question was not saying only have those elements. So fine. Good. So now we want to move into solar cells. So we're not going to look at all the entries, but the one which are about solar cells. And we want one which has this absorber layer that we want to use, this whole transport layer, and this electron transport layers. So let's go. Where did I put my nomad? So you go there for the solar cells. And let's scroll down until we find what we need. So, absorber here. That's the one. Transport layer. Electron transport layer was a crystalline tin oxide. This guy. And the whole transport layer was this strange name, spirometad. Okay, so here we go. We are left with 251 results. That's the one. Okay, you managed to do it. And then when it gets interesting, maybe is to see the range of efficiencies of solar cells that have been reported with these materials. So maybe I'll let you try it a bit. if you have already the filters, yeah. Yeah, tell me. Oh. Yeah, sorry. So, exactly. So we were in a case, I can do it again. When I'm looking for an entry, I could have done it just from there, but I don't want to go through the whole table. But I know what I'm looking for is an element, right? So I started by typing that. I want an element, so I type an element. And then, okay, forget about this because it's there because I typed it before, but it's not going to be there in yours. What I want to know is how this field that contains the information about the element is called. So I'm scrolling down the field, and I'm looking for something that looks like it. And this is this one. You can recognize it because it has basically the same structure as here. So you have results, okay, which is implicit, but then you have material and element. So you can recognize this is the right name of field you want, and then you just give the values for it by equal and iodine, for example. And then same. And what was the last one? Bromium. Okay. You have them? I can put back this to check. No? Oh. Let me have a look.
Result material.
Yeah, that should work. That doesn't work, right? Right. So, element. There.
Okay, good.
Ah, yeah. And then the 3 other elements. This is the solution. Yeah. You managed to search the solar cell structure? Yeah, so there's now we have the solar cell with this element, but on top of it, we want that it is the absorber layer of a solar cell. So for that, you need to go to the, yes, exactly. Exactly. Good. So is it solar cells? Check. Absorber. here, and it's this one we want. And then you have the other layers. So we want a transport layer, whole transport layer, which is spiral something, and an electron transport layer, which is PiO2. So we can just go on scrolling down this metadata that exists about those layers. And this one is here. And the whole transport layer is here. Exactly. So we are. Oh, well, sure. Well, this one is a bit out of the scope of this, but basically you have your solar cell here, and when it's absorbed light, it's going to generate charges, and you want the current to go only one direction, right? So you want that going up, there's only electrons going, and going down, there's only holes, so counter charges going down, so that your current has a given direction that it doesn't cancel out. So you can deliver a current with your solar cells. So those are what those layers are doing. They are making sure that only one kind of charge goes there, and only the other kind of charge goes there. Yeah. No problem. Yeah, so the answer I found was 251. I think a few of you found it too. So next one is, now you have your 251 entries. How efficient the solar cell were for those entries. That's getting more interesting. And so what they suggest you is to use a histogram widget. Let me just display the next page of the Menti. Oh, sorry. Answer. And yeah, so they suggest you to go on Nomad and use histogram widgets. I'll give you a bit of time to give it a shot. Good. Yeah, let me show you. So let's go back to Nomad. Blue. So they suggest you to use a histogram widget. So the one here. And then you're going to show a histogram. And for example, you want to show here, this says the efficiency, I think. So let's go for efficiency, which is this one. You can give a title to your axis. Efficiency, solar cell efficiency. And let's go. And here you go. So it give you this widget in which you can see that all these 251 entries have efficiency running from 0 to the maximum one, which is around say 17, 16 point something electrovolt percent. Sorry. Good. Yeah. No, in that case, and I don't know why they didn't put unity's percentage. So it's a percentage of the power of the light that becomes electrical power. Yeah. Well, they just wanted you to display the range. So you have displayed the range here. This is a mission accomplished for this one. Yeah, I got that. Yeah, so you just have to say that you managed to do it. Just wanted to check this. And then for the next question, the next question was to show more than the efficiency, but all the information, like which kind of current goes through it, which kind of open circuit voltage. It's a little bit more tricky, but the hints should help you. So I'll let you try it a bit. Good. So let me do it in parallel. Okay. So in that case, it's a scatter plot tool, and what we wanted is to have the open circuit voltage. This one. So you see, all right, you start typing and the thing appears. You can change the unit if you want. You can put it in volts, so it's easier. And then the efficiency that we have already seen before. There's no unit, I believe. And you can use the color of the markers as the third axis for the current. Maybe. Yeah, and it gives you that. So you can really compare all those 251 solar cells that has ever been produced, or at least put into this database to the solar cell you're trying to do. So you already know the state of the art, you already know what to do, you already know how good a good solar cell could be and how bad it is. So you can really position yourself, and then you can add more parameters to maybe try to understand what makes those ones so good, what makes those ones so bad. Yeah, exactly. So, yeah. Good. So that's it. And again, all that can be then done by code. As usual, you can have access here to all the code that corresponds to what we've just done. If you want to put it in a program that's going to be able to call for the right data. Yeah. So I think it's very powerful that you can really compare yourself with literature, compare yourself with what the rest of the world has done, find other works which have been done maybe with the same material, and that's how really useful and powerful data should be. Yeah, and I think that's it for the moment. Do you want to take a break? Coffee, water, cookies? Yeah, so we were discussing an example of an application. I was saying before that once you have this database in your data in your database, you can get all this done automatically and fed with those programmatic code into another algorithm to feed a machine learning, for example. And this one was an example of it, in which they used data from a database in Harvard, and some more data and some measured and some measured energy level to predict the energy level of some new molecules by training machine learning from existing molecules. They translated the molecule into a set of parameters, and now knowing the parameters for the new considered molecules, the machine learning was able to predict the energy level of these molecules with a fairly good accuracy. Here was a validation one, so this was measured energy level compared to the predicted one. So you can see that there is sometimes a bit of deviation, but it gave you a good idea to start. And then, for example, if you want to use your molecule for a certain application, maybe this prediction is going to be good enough to know if it makes sense or not to try the molecule or not. So that can be really powerful. Yeah. So, yeah. Okay, so that's what you can do once you have this material. So now the question is, how do you bring the data is there? So let's see how to publish data. Exactly. So again, adapted from the training by FAIRmat last winter. Exactly. So how do you go from your raw data to some published data sets? Ideally with a DOI for which you can be cited also, because keeping credit to those sort of things is also one of the important things of FAIR data. So from there you will need a Nomad account, if you can create an account. I don't know if you have already created one. Do you already have an account? I think it would be easier if you can create an account. If you're on Nomad, it was on the top right. I think they just need the affiliation name and email address. Because yeah, to read the data which is there, you can do it as a guest, but to upload data, you need to have an account, which makes sense. You don't want just any automatic program to spam the database. So yeah. So for you, you're gonna have to register. For me, I'm just gonna have to log in. No. What happens when I save my password is that I forget it, and the time when I don't have it anymore, I I don't have it. Oopla. And also, if it's saved, well, I'm protected from outside, but if someone arrives at my computer, then you can use all what I have. Yeah, so we can delete all that. We're not going to filter anymore. Did you manage to create your account? Or... Yeah, you can do it. This is a safe thing. You can use your KAUST email address. Yeah, that's a very good question. Let me check. I think once you have, so you would have before leaving to probably update your email, even after, because KAUST will leave you your email address for a little bit of time before the end. For students, it's forever, or almost forever, but for like postdoc and research scientists, or even professors, it doesn't stay forever. Only students. I think students stay forever. I'm not 100% sure, but yeah. Right? You always, even if it's forever at the moment, the policy may change in the future, and they may decide something. But you can then change. You see, if I go to my thing, I can then change my my email. I can change my affiliation. So that's how you would do it. I don't want to change it now. Oh, yeah, I can change that because I made a typo here. Like something stupid. Yeah. Whatever. What if I do that? Yeah, you see it updates without problem. So yeah, that works. So you can update your affiliation and it still remains you. So yeah, you are safe. But that's a good question. Would be interesting to see. I think you, as a user, also have a unique identifier. So things which have been attributed to you remain to you even if you change your email address. But to be confirmed. Oh, probably. No, ah. Of course. That's the problem of changing my email, is that I need to verify the address. Oh, that's okay. Oh, well, yeah. It's a constant fight, you know, trying to order the new things, but also trying to not do only that, you know. Anyway, you have account, so let's get started. So a bit of vocabulary, the things which are involved here. Uploads is a set of files that you bring in to put it on this repository. A project, what I call a project, is your work out of Nomad at KAUST, for example, or somewhere else. An entry, you've already see what an entry is. That's a file that has been uploaded and that Nomad can understand, so it's able to create this very organized data representation for it. And a data set is a group of entries that you group together because you estimate they are related and it makes sense. And then you can publish them and also get a DOI and be cited for it, for example. Exactly. So that's what I just said. An upload is where you put data. It can have several files. It can come from different projects. It can have the structure you want. And that's what we're going to do first. An entry, that's the thing which are generated automatically by Nomad upon uploading some files, if it can understand the file, if there are some things that are following one of the standards he knows. And those are the one you can view in this exploration page. And so files become entries if Nomad can understand them, which means if it has what they call a parser, which is something that explains how to read the entry and what are the fields that should be created from it. And datasets are a group of entries which you consider are relevant to have together. An entry can be in multiple datasets, an entry can be in no dataset. It's really your choice. Exactly. And typically, a dataset is going to be what you reference in an article, which has the data that belongs to justify this article. Exactly. And you can have a DOI for your dataset. So yeah, what we're going to do is to create some uploads and see a bit how the interface works, how it can be shared, how you can credit properly all the people who collaborated to this upload. Exactly. So let's start. So to do that, it's in the publish part. We've been playing with the explore so far, and now it's in the publish part, and you're going to be publishing an upload. So you put an upload here, and I already have a few, which is good. So I did not lose them even if I changed my email. It was a bit the scary part, but it worked. For you don't have some yet. You're going to just create a new upload, and it brings you to this interface, which is the upload interface, which is in two parts. You have the overview and the files. So before doing anything else, maybe we're going to give it a name. Okay, I'm typing. Oh, sorry. Big fingers. Save it. Don't forget to save. There's no to save. It's not Microsoft Word, so you may have your last changes disappear. And if we explore a bit, here you can say that it should belong to a subcategory of entries. Here you can say that you have some more cursors to it. Maybe you can try to invite your next cursor to it. You can try it. Has one of you created have you created some account? And I don't know, one of your emails, whichever. Is that secret? You all have too long names. Okay, I'm gonna add one of my students because I know I will find him more easily. No? Okay, sure. You have already validated your email? Yeah, I would not have guessed, probably. I'm sorry. It's not validated yet. It doesn't appear yet. Okay. Maybe because you just added it, maybe it doesn't appear yet. I don't know. But yeah, that's how it would work. Yeah, but you should already be there. I mean, so. But you see how it would work. Yeah, but I erased your name. I'm not going to be able to type it again. I can, yeah, I can add myself. I will. Sorry. Oh. Are you already ready? Oh. Here. Good. An easy name. Perfect. And you can choose. I can choose you to be either really a core source data, or just someone who's going to review it. Okay. So you're going to be core source. No, I think I put reviewer of my data. And that's it. At the moment, the other options are not open yet because we haven't put any file. Once the files are here, they're going to appear here, but not much to do unless we put files. So let's put some files. Have you downloaded the files? So let's start, for example, with some files which are random files, something which Nomad cannot recognize. Okay, so they're called here in the miscellaneous files. And one convenient thing to do is that you can just take a compressed folder directly. And then it directly uploads all the files. Okay, and so they are uploaded. You can see them in the file view now. And for each of them, you can have a preview of the file. So one was this logo, one was this logo, one was this logo. And if this kind of format has some existing tool, you can have access to it from here too. And now, yeah, exactly. So that's it for files which cannot be understood. The other way to put some is to use this button and just add some files. For example, those ones. Look. And same, if you go to the file view, you're going to go see all your files. Some is a PDF, for example. There is a normal text file. And you can also organize them. So from here, you can, for example, create a folder. You would like to call it articles. Up. And you could put, for example, this file into, oh, sorry. This file, into this folder. This file into, yeah, actually it was doing the right thing, right? Into this folder. And then you organize your folder the way you like. Okay, and then I have my 2 articles here. Good. So now that we have some files, no, we cannot do much more yet because those files they can have a preview, but they cannot be converted into entries. They don't correspond to some organized data like the ones Nomad can display. So now we want to put in some files which are the ones for which a parser exists, the ones that can be really become entries and be displayed in these data sections and visualized and so on. So let's do that next. This is a simulation of some iron oxide. So I'm going to create a new upload. I'm going to do Nomad test simulation. Look. And same. I'm going to upload these files here. Look. Yeah, sure.
Potential human house here one what
So there's a different way of using your data. So one way, if you want to share nothing, you can put it here and not have it public. Okay. So then you can compare it with the data which is already there, plot it together, and you see how your data fits into the big structure. In the big picture, you can use it together with those existing data to maybe fit an equation to the trend of what you see. There's also another option. So Nomad server is in Berlin, but we also have a local copy of this server here in KAUST. So then it's accessible only to people in KAUST. So this is another thing. Another thing, you probably don't want to upload your data when it's still under work, but maybe you want to upload it later when it's published, because you can be cited for it, it can be reused, and people reusing are going to cite you. It can be, it really increases the weight of the impact of your data. And you can publish it, but with an embargo period to be sure that your paper is out before the data, for example, or things like this. There's different ways you can use it. So the way there's a bit of both. There's a bit of several things. Like the way I see it, and the most important for me, is to stop wasting our data. Because our data basically is published in a paper, and then halas, if you want to reuse it, it's very complicated, because you're going to have your data which just going to be in a figure somewhere, but the raw data, you cannot have it directly. And the information about the data is going to be in the experimental section, and who wrote it is going to be in the title. And so this is totally inefficient. So this stops these things. At least when you publish new paper, you can have everything together and access directly all the information together. And what I think is that you have really a leak of information and a waste, and before cleaning the kitchen of all the water, you want to stop the leak. So you want to stop wasting your data. But on top of it, of course, there is some programs which are trying to read the existing data, but the way articles are done at the moment, which is really a 19th century way, really. It's really paper and some figures, and it's just very complicated. What they do here, for example, also, because there's other databases, they try to import the data, which is also linked to the data which is in the other databases. If you go to the exploration, and Alexandria, for example, this is all data that come from another database which is called Alexandria. Which they are currently uploading, and which has also a lot, which has 2 million inputs, for example. So, because the problem, that's what I was saying at the beginning, there's not a single solution. FAIRdata is recent, so people are creating things here and there, and we're really trying to bring them together. So that's, I don't know if that answers your question a bit. So this is a bit not totally correct, because if we go to Nature, for example, the article itself is strongly copyrighted to Nature, and because the publisher wants to have the money for it. But the data it's very explicitly said that you should try to make it available. So this one, for example, is all the data is on Figshare. And it's natural. It's Springer who asked me to put it somewhere. It's not even I went against them to do that. They asked me to do it. But the high impact journal often ask you to make the data available because what their thing is to fight against retractation, against things that pull some figures, but you cannot find the data for it, so you cannot really prove it. So they really want to have the data available. The problem of Figshare, if you want, is that it's just some space. You put your data the way you want, and it doesn't matter if people manage to read it or not. You just throw things like this, and that's what I did here. Mm-hmm. No, I don't think there is any team working on this. So it's exactly. At the moment, it comes from the author. I don't know if some other groups are working on backtracking the things that have been published before, but as I say, it's cutting the leak. No, exactly. And as people trained in this, for me, for example, what I want to do is to make it as easy as possible to upload the data. I'm going to show you the normal way now, but I'm going to show you also how easy it can become if you make a bit of more work around it. Where was I? Here, publication, my upload. So we can come back to the one upload I was working on, simulation, this one. Okay. So when I uploaded that, it created this, which is something that can be understood. So it did create one entry that you can see here with your iron oxide, some electronic property calculation on it, and the workflow of how the calculation were carried out, for example. You can see all the files which are in that entry. There's quite a bit of them. And you can see the data directly. So without this front end that will give you some nice visualization. All the data always have a result part, which have different fields. And metadata part, which is the data about the data. So like what program was used to do it, when was it done, and so on and so on. The licensing, very important. And for this type of data, you have additionally the workflow that really explains the method that was used to produce the data, and the run, which explains, for example, how the process of the calculation did happen. Okay. So once you have uploaded some data, you can do more things about it. You can add metadata. So if you have several files, you can choose here to make metadata, which would be only about that one file or that one entry. Or you can choose here to do it about all the entries. And here you can say whatever you would like. This is I produced when I had this headache, but it still worked. You probably would want to make some more useful comments, but at least you can. If it's, for example, published in an article, you could put here the reference of your article, so they're really going to be bound together. And if you want to make it part of a data set, that's where you would put it. Exactly. And once you have your data here, you can choose here to publish it. Means at the moment you're the only one who can access it. Okay, no one else than you can see it. if you choose to publish it, it becomes visible for other people. And you can choose to have an embargo period so that at least during those 36 months, you're still the only one who can see it. At any time during the embargo, you can stop the embargo and make it published. But the thing is, what's in publish, you cannot change anything. Of course, if it's published, you want it to be trustable, to not change from one day to the rest. So it has to be ready. What you can do if you want some people to see it, but you still want to modify the data, you're still working on it, you can enable the visibility, which is not equivalent to publishing. It just makes other people can see it. So yeah, that's it for this one. Then I would like to see, we've done that. To see, you can also upload some experimental data here from X-ray spectroscopy measurement, for example, which does have some parser to understand the data. So I'm going to create a new upload again. My tutorial experimental look. And similarly, I can bring up this data. For example, this one. So NXS, it's a Nexus format. It's a format which is already fair data, which already has all the information about the data, like the processing condition, how it was done, and everything. So you can see now that the parser is working. It's working hard. It takes a bit of time to interpret this data that you uploaded. And so the data is there. And yeah, it created the data. You can still add some more information, like it was done in KAUST, Core Labs, for example. But the main data is here. So this data set contains 3 experiments. And for each of them, you have the precise description of the experiment, the instrument, the user, very important, as I said before, that once you upload your data, you are safe. Your name is going to be attached to it. Yeah, and the sample preparation, what sample it is. There could be some link to some other experiments done on this sample. Something like this. What's the name, of course. And so on and so on. So this is what happens for data in which the name of the data, the format of the data is very clear, and Nomad recognizes it immediately as something he knows. Now, typically, your setups are going to give you data which are some very common name, .dat, or maybe just some ASCII files. So what can you do in that case? Like, for example, for this same experiment, the setup gives us data which is an XML format. XML could be anything, basically, right? So in that case, you have to tell Nomad what it is. And for that, you can invoke a schema, which is going to replace the parser. So I could say XPS from schema. And now I'm going to look for schemas. There's a lot of built-in schema that you can use, or you can create your own. So here I want to use one which is called data converter. Let's use data converter. Is it the right one? Let me check my notes. Let's see. Chook. So that converts this program into Nomad, into Nexus file. So you have to tell him how to read it exactly, because this schema contains several kind of instruction to read several kind of files. So this is XPS. And the final format you want to do at the end is called NXXPS. And that's it. Then you can give him the file, which is, again, XML file. Okay. And he's going to do what he did before. He's going to convert it to a Nexus file, so something in FAIRdata. If you have more information, for example, about the experiment, which is not output directly by your setup, you can add them here. Here we have an electronic lab notebook, which contains the information about the sample preparation. And you input it there, and then I save. It's still being processing. Need to wait a bit. And once it's processed, it will display the Nexus view. Yeah, now save. Yeah. Mm-hmm.
I will get what like raw material without charge. I mean,
Yeah. So here what I'm showing you is uploading the raw data. And I have it now. So there's one category. If I refresh, maybe I can see it. So this, I think this one has only raw data, okay? But what you can do when create, we have section about the step, the entry, the instrument, the results. You can have one more section about the data analysis in which you will explain, and it's not there in that example, that you have processed this that way, maybe by a fit of the edge of your valence band, or no, it's XPS of your band, or a fit of multiple Gaussians, and give all the parameters of your fit and the conditions into fields which are going to be like this. And then once you have want to compare more data, you will be able to choose the one which have the same way of fitting the data. So because you know those are the one you trust. Because at the end of the day, that's exactly what you want, especially for UPS, XPS, when you have so much variation if the things are not done well. You want to have these kind of filters to know what you can trust or not. But it's all under construction, so you may have to create it. That's why I want you to have hands-on training to know how to do things. Yeah, exactly. So that's how it is when you have a format which doesn't have a parser embedded directly. And the last one thing I want to say about files is, just done that, is how to group them in a data set and get them published and get a DOI for it. So that's pretty easy. So to see your existing data set is the same. You go to publish, data sets, and you can see all your data sets. I have a few of them. Most of them are not published, but I have one which is published, corresponding to the article I was showing before. But how to bring your data into those data sets? So you just go to your data here, and you saw it before when I was showing you the metadata about the data. For example, I want to put those two. here, I can make them part of a data set. So either I create a new data set here, or I search for my existing data set. I don't know, this one. Oh. So now if I check the metadata of my thing now, you can see that it is part of a data set. And if I go to this data set, either by clicking this button or by going back to publish data sets and finding my data sets, this file is one of them. You can see it here. That's the one I just added. You can see both of them. And then once you have this data set, which I'm not going to do now, but I'm just going to show you, you have this button to get a DOI for it. So once I assign a DOI, your data set is going to have a DOI and you can be cited for it. There's actually a few journals which are just for data sets nowadays. You give a title, you put your data set, and you have your data there. This comes together with development of AI when those data sets are very important. Yeah, so that's it for putting up some data. Done. Yeah. So, well, you could go to, well, no, we are only a few, so maybe you can tell me. Well, you can also write it there. If you want to write some thoughts on the Menti, and you can also tell me now directly while I'm starting the Menti. Yeah, ask me questions, please. The data set is just a list of entries which are connected together, or it's basically a link to a series of entries. It can be different format. Is it saved as a JSON file? No, I don't think so. There are different formats, really. I think the metadata for it is probably stored as JSON file. But for example, if you see the XPS data we had before, it is the Nexus file is just like this as a Nexus file.
So we need to prepare to re-upload or
So either you prepare it by yourself to put it in this Nexus format, for example, or another format which is recognized, or you work there and you create the parsers that are going to be able to understand your format and display it the way which is useful for them. I can show you. I have some slides about this just before, because that's something I've done. Cool. So, but yeah, one thing here is that my own feedback to myself is that it looks like a lot of steps for little results. But this is because this is just the introduction, and I'm sorry that for the sake of time, I have to stop before reaching the. I'm going to come back to your question. That's an example I have later. Before it really gets interesting, on the tutorial online, there's the fourth part, which I'll not have time to do like this, but which is how to include that. It includes at least how to develop your own parser to understand your data and upload it directly. Because you don't want to explain every time, no matter how to understand it. You want to give him the schema of how to understand your data and then to use it to get it. So, for example, this schema, we've seen we could generate data from a schema. This schema can be how to read the electronic notebook, or so how to get all the information about your data. For example, I had one student making it some time ago. Where is my Nomad? If I go to oh, this is the data sets. Here, the SRSI students, so high school students coming back this summer, and he developed this schema for solar cell data. So and custom schema, so that's one we have done by ourselves. And how is it called? I don't know what it's called. No, wait, not only mine. No, that's Yep. Oh, he was there. Yes, this one. Look. No. Just a bit slow. Yeah, this one, exactly. Processing of organic solar cells. Yeah. And then it has several schema within this file. And this one was, for example, to input the information about the solar cell. And then it pre-creates entry. It creates an empty entry in which you can put all the information about your solar cells, for example. So this is basically an electronic lab notebook, a new page of electronic laboratory notebook in which you can put all the information you want. I have a substrate, it is a glass, sample is, I don't know, sample JG5, and how you've been cleaning. So all the things that you would write in the notebook, you can write here. So you can have a very systematic description. And then for each layer, you can add how it was processed. I can add some steps here, for example, in the deposition of this layer. And so on and so on. So anything you would write in the lab book, this is a electronic laboratory notebook, basically. You can put everything in there. And then each of these things will have a field which is searchable in Nomad, like we've seen in the beginning when we were searching. So this is one thing. Another thing is you can create your own parser. And this is something I've done for UPS, actually, not exactly XPS, but UPS. So a parser is something that knows the format in which you want to end up. It knows that you want to have something which is going to be an access file, for example, which is going to have a field about the experiment, a field about the instrument, a field about the sample you put in it, plenty of fields. And he also knows how your raw data is, what your setup outputs, okay? He knows that in the header, you have this information, this information, this information. He knows also how is your own data, the one that you did by yourself, that documents what you have done. And so this parser, what it does, it reads those data from those two files and it puts them in front of the right category in your Nexus file or in your JSON file or in your YAML file, whatever makes sense for you. And then it outputs a file which is a FAIR file. This takes really one line of code to call such a parser, but sometimes you don't even want to have one line of code, and some of your users are allergic to code. So, for example, in that case, I created a GUI interface for it. I don't know if I can run it here. Terminal. I had a terminal before. Yeah, terminal, not a PowerShell terminal. Open new terminal. Yeah? No, not what I wanted. Sorry? View? Thank you. Ah, great. Don't want the bash, I want the PowerShell. You have it in mind how I get the PowerShell one? Right? No, I definitely have it. Ah, sorry. Yes, okay. I was waiting this, but I need it to be PowerShell. Oh, thank you. Up. So this is, for example, my interface, and if I take some example to setup, PS, UI, examples. VMS is the raw data. You may know this format. This is a spreadsheet in which I have the information for this measurement, and this is the one that describes the setup, basically. And everything there. Come on. Ah, I moved them somewhere. Where did they go? They go on my desktop? I don't know. Okay, that's stupid. I lost my example. Well, then you're gonna have to believe me. I put those 3 files here, and then I click update, and it brings the information from the user into the overall information. So it combines information for the user for this measurement plus the information that describes the setup, and then it generates an access file, and then it uploads it to Nomad directly. So, you know, it doesn't take some time for the final user to make those things. So yeah, it can be made simple, but I cannot go to every setup one by one and make that. So I need some people who are able to do it. Yeah, so that's it for this. As I said, Nomad is just one solution among many. Maybe some are going to raise, some are going to become prominent. At the moment, there's just different solutions for each field. For the electronic laboratory notebook, I found those one nice too. So that's something that could be interesting to try if you're interested. If you know other examples, I'm very happy to invite some people who know about them and present them. Because, yeah, again, there's just many solutions, and I have to know as much as possible to choose the best one. As I said, we have a local Nomad Oasis, so for which you can put your data, and it is in KAUST. So even if you publish it, it's going to be published within KAUST only at this stage. You can find some case studies for computational material science, for example. We had a guest 1 year ago about this. Nomad Camels is interesting because it's enables you to code your setup the way that it creates directly fair data and that you can directly from the setup upload it to Nomad. The YouTube channel of FAIRmat has a lot of videos with a lot of different case studies. So, yeah, that's it. Thank you for coming. Thank you for staying. Oh, yeah, please.
There is no database. Provide the link.
Oh. That's something I would encourage you to ask on the Discord channel. I shared before the Discord channel link, and they will know if they have some people who can be available to do that. Most likely, I guess, they would try to guide you toward doing it, because the people who are working on it. So one of the reasons I choose Nomad is that it has a critical mass. There is a FAIRmat, which is the parent of Nomad, has like 60 people working for it. But they are very busy developing those parsers and for all the field. It's for material science in general. So you saw this is XPS, but already XPS. You can think of 10 different parsers for the 10 different typical setups. So I'm not sure if they have some manpower is ready to search and upload data from existing paper. They do it from existing databases. They transfer from existing database to be referenced in Nomad. From single paper, I'm not sure, but it would be worth asking. That's a topic for which we had big discussion. I was in some meeting like 1 year ago in which we're trying to define what would be the standard for optical spectroscopy. And we say you can provide this field, this field, this field, like which light would use to make your measurement, what sample, or the geometry of the sample compared to light and all what you want. And there are already two schools. There's a school that wants to make every field mandatory to respect the standard, or as many fields as possible, and the school that says you're gonna make the fields optional or recommended, but not mandatory, so that the people who have a homemade setup in which they don't have something to measure the spot size, for example, of the beam, can still upload their data. And there is this discussion really on what has to be the minimal quantity of information so that you validate the dataset. At the moment, there's no minimum because it's too early, and you provide the fields, but you don't reject things. Now the field exists, and you could filter through them to think, this data doesn't provide this information, I don't think I can trust it. But reference to a given paper, the references are there. I'm not sure if you can filter through it because they're just text. So, yeah. Mm-hmm. Yeah, like if those exercise data, if I press publish, for example.
What's the problem?
I will have to look it up. There's no work about provenance really. I think the logic is really that if the data is well documented, you can use this documentation to decide if you want to trust it or not, the existing field. And it's definitely not filtered per journal when it is published. And I can give you one good reason for it, a very good reason for it. If we check the example I had before, here, okay, if you want to compare some data to find the general law that governs the things, maybe this data point is not going to be published at all, or it's going to be published in a very low impact because the efficiency is poor and people don't want to publish things that don't work. Or if they publish things that don't work, it's probably going to be in a low impact journal. And yet it's like the most important point, because if only those ones are published, you're never going to figure out what makes it work or not, right? So I think my opinion is that filtering per journal might not be the most relevant thing, and I don't think there is a functionality like this in Nomad, because the data sets are uploaded in Nomad as data sets, and they can be linked to a journal, but they don't have to. And if you want to share your data even before it's published, it's fine, and no one's going to stop you. So you're gonna have to find a criteria that makes you figure out that it is wrong. The journal itself will not be considered as a good criteria. So author is a filter you can use. If they have been written as authors, and I think they will, because this kind of authors want to have their name everywhere, then you can filter according to the authors. But of course, you need to know the authors you want to filter out. But otherwise, you're going to have to find a criteria, like the information is not well documented, or there's no actual data that backs up the numbers they give, or those are criteria you're going to have to find. But the criteria is not going to be journal or not journal. You need to have some criteria that you know, that you figure out, that tell you that you can filter things out. Yeah. A scientific criteria. But you know, things which are not trustable usually are poorly documented, so that you cannot find the thing that is wrong, right? So having this documentation present or absent, in my opinion, in many cases, could be a good criteria already. You just have to find this one parameter that makes it that you can trust or not. It's not no.
Like, what about your
Oh yeah. Once you have your data set, so I can show you one example in this article actually. Yeah, exactly. Why don't Okay, this example is done very poorly. Normally it should be there. So, but it's okay. Normally it should be in the supporting information in the open research, and it would refer to the DOI of the Nomad thing. Here it's not been done well because it was the first time we did it, so we didn't do it right. It just referenced here. Okay, but yeah, this is a data set. It has a DOI here. You can see the DOI here. And data sets are precious and they are recognized as such. Like if you go, for example, I think it's this one. No, but it's referenced here. This one. So I'm not 100% sure this one is one of them, but there are some journals which are only publishing datasets without any text about it or just a metadata, but not article explaining what it is. And people get cited for it. I'm not sure this one is one of them. From the title, it could sound like this, but I don't think it is. Show them the library, the repository. Yeah, I used to have the link. I forgot it. I removed it. So repository, and they have a. You know this repository probably because it has all the. When you publish an article, you're supposed to give it to the library so that they add it. But they also have some data sets. You can also put some data sets there with DOIs. You could get a DOI actually. So this is possible. It's in a sense less interesting than the discipline repository like Nomad because it's not searchable according to scientific words, for example. But you get a DOI for it. And my fig share I showed before, I don't know if it's still there, has a DOI too, and it's cited by my Nature Materials article. So that's the important thing, that you keep credit of what you are doing, and you can credit the people when citing them. That's a very important part of the FAIR principle also. Yeah. But yeah. Exactly. Other questions? You asked the two? I think you had two. Good. Well, thanks again. And again.